Hello everybody, I'm Christina Ginzu. I am part of the technical support team of Pix4D, and I'm going to present today's webinar about how to import Pix4Dmapper outputs in software like GIS, CAD, and more software. Let me just a second. The title of this webinar might sound familiar to some of our followers. This is because we have done a similar webinar in the past. You can find it in YouTube. It's called Pix4Dmapper Outputs in AutoCAD and ArcGIS. Today's webinar is not just a repetition of that old webinar. We wanted to make something new, something fresh, and this is because we have now more outputs and we have more software with which we are compatible. So here we are, we decided to do this new webinar. Before starting, I would like to comment that if you have any questions, feel free to type them and our support team will reply you. And you can always send us mails at support@pix4d.com with your questions, your feedback, your suggestions. So let's start. Pix4Dmapper generates plenty of outputs. I try to collect here the basic outputs, the core ones, the ones that the majority of our users use. Let's see, for example, the orthomosaic. If you are interested in 2D information, let's say you want to measure the width of a road or the width of a window on a facade of a building, then the orthomosaic is a very good output for you. It has also color information. Practically, it is a 2D reprojection of your area. As a 2D projection of your area, it doesn't have altitudes. So if you are interested also in altitude information, then you should work with the DSM. The DSM does not have color. It has altitude for each pixel of the orthomosaic. Then if you are interested in fully 3D outputs, X, Y, Z coordinates, you should go for the point cloud. The point cloud has the coordinates for several millions points of your area, and it's a very good output for inspection, visualization, 3D measurements. The next step is the 3D texture mesh. We don't just export points, we apply a surface on these points in order to give a more realistic result, a more realistic output that could be used for presentations, for cinematography, for video games. In general, it's a very cool output that will be used more and more in the future. Last but not least, if you work in the agriculture field, then very probably the output that you are interested in is the index map. The index map, it's a map that does not have color, does not have altitude. It has information about your plants, about your agriculture fields. Depending on the formula you used in order to create this index map, you should be able to take some information about how healthy are your plants, how much water do they need, etc., etc. Let's see a bit closer these outputs. Let's start from the orthomosaic. The orthomosaic is an image file. You can open it with any image viewer and you will be able to see colors. It's also a GOT file. This means that if you have a project with georeference, and what georeference means? Georeferenced project is a project that has some coordinates. Either you entered to your project the coordinates of your images or the coordinates of some known points of your area, what we call ground control points. Then if you enter that kind of information in the project, then all of your outputs will be georeferenced. And this information is included in this GOT file, the file of the orthomosaic. So if your project is georeferenced, you will be able to open the orthomosaic georeference file in a software that can read this georeference and place your model, your orthomosaic in the correct place on the Earth, and each pixel will have correct coordinates. The same happens for the DSM and the index map. Both are GOT files. They are not exactly images, they are raster files, but they don't have colors. So if you try to open them with a normal image viewer, you will not be able to see anything because it will be all black and white or just gray. This is because a normal image viewer cannot understand the information that is hidden per pixel, because it's not color information, it's altitude information and index index information. This is why you should open these outputs with special software, with software that can read this information. So you should open them with GIS software. Later on, I will show you how to visualize them in such software. Then we have the point cloud. We export it in several file formats. The most common one is the LAS. Then the 3D texture mesh that we exported in OBJ, PLY, FBX, etc. And then once more an overview of these outputs. And then I was here saying to you that Pix4Dmapper generates more outputs. It generates contour lines, generate digitized objects such as polylines, points, etc. And classes that we will see later on what is this output, and more files. Almost all of these files can be visualized into Pix4Dmapper, so there is no need to go to other software for the visualization, for analysis of these outputs. But of course, we understand why the compatibility of our outputs with other software is important for you, and this is why we make this webinar. Let me show you now how you can import the 3D texture mesh, that it's one of our new outputs, in different kind of software. Let's firstly open it in MeshLab. MeshLab is a free software. Let me open it here. So you can open in MeshLab either the OBJ file or the PLY file. Just drag and drop any of these files. It's loading. Well, it's loading, and apparently it takes more than the usual. This is because I have too many software open at the same time. Let me do it once again with the PLY. Just a second. Well, it takes, okay, I will show it to you at the end of my presentation, while I will have closed all of these, of the rest of the software that right now are open in my desktop, because I'm with a laptop and it takes more time than I would expect. Let's see how to import the 3D texture mesh in software like Rhino or Rhinoceros. Rhino can import either the OBJ file or the FBX file. FBX file format is a new format that we will generate in the new version that is about to come. The new version of Pix4Dmapper 2.0 will export the 3D texture mesh in DXF file and FBX file format. It's our new output file format. So Rhino can import either OBJ or FBX file. You just need to drag and drop it. The software will ask you what to do with this software, with this file. You should click import, OK. Just click OK in the default, leave the default parameters. Let's see, I hope it doesn't take too much time. If it takes too much time, I will close the rest of the software I have open, but no, here it is. So it's now imported in Rhino. To better see it, okay, you have to go here in Display tab, here. Then shade. You see, let me maximize this view. Maximize so we can better see it. And then there is this other button called rendered viewport that makes your model rendered. Here under the tab standard, you have navigation options. Let me click the rotation. And here you can see your model with texture. Once again, I have to click shade and texture, and here it is in Rhino. I will close Rhino to not having everything here. And let's see now how to import our 3D texture mesh in 3ds Max. you can import the OBJ or the FBX file. Let me open it. Let's drag and drop this time the FBX file so you can see it better. You can see different kind of file formats. So we just drag and drop it. We can maximize here one of these views. Let's maximize this view, for example, front, maximize, and then to see better your model, you can rotate here. And to see it with realistic texture, you have to go here, wireframe, realistic. Please note that if your models have the correct scale, if you have imported this information into Pix4Dmapper, then the output will also have the correct scale. Let me show you an example of a project that has the correct scale. Here it is. This model has the correct scale. So if we measure a distance, let me measure it from the beginning. To measure a distance, you have to go here in this button, create, to click this button, create, then helpers, then tape, and you can make a measurement. I will measure this part of the model. On the right, you can see you should focus here on this part where it says length. I will make once more again the measurement, tape, and you just drag your mouse. As you can see, the length is 90 meters. Let's open now the same project in our software. I have already made the line here. Let me do it again. I can remove this polyline. And I will draw a new line so you can check the same distance into Pix4Dmapper. Okay, here it is. You can see that it's almost 90 meters. Of course, it depends on if I click the exact same points or not, but you can see that the scale is correct of the model. So the 3D texture mesh that we export has scale. To come back to my PowerPoint, you can also import our 3D texture mesh in Global Mapper. You should import the OBJ file. You can also import it in AutoCAD. I have tried it with AutoCAD 2014. You should import the FBX file. As a recommendation, I would recommend you to not import very heavy files in AutoCAD because it takes too much time to load and it's not easy to navigate to them, to work with them. As a recommendation, I would tell you to export a 3D texture mesh with less than 300 triangles. Let's see now how you can import it in AutoCAD. I have taken some screenshots for you. So you open AutoCAD, you have to go to the tab Insert, then Import. Then this window opens, Import File, and you should click the FBX 3D texture mesh that you have generated from Pix4Dmapper. Then if you are interested in just visualizing the outputs, not making measurements, you should click OK. Then the 3D texture mesh will be loaded, but as you can see, it will not have realistic form. You should go here in View, and then click this Realistic button, and then you will be able to see the model in AutoCAD. Now, let's see how you can load your 3D texture mesh file in Sketchfab. Sketchfab is an online application. It's a place where you can store your models and also share them with your clients. You don't need to share with your clients the full folder with subfolders with all the file formats that Pix4Dmapper generates. You can just upload your project on Sketchfab and just share a link, a web link with your clients, and they will be able to open the model and navigate on it. Let's see how easy it is. You have to enter in the main page of Sketchfab. The first thing you should do is to create your own account. Once you create your account, you take 50 megapixels per model for free. And later on, if you want, you can buy a special account, a pro account, if you want to have more space. So once you create your account, you have to click the button Upload, choose File, and then you should click the zipped file that Pix4Dmapper generates. Pix4Dmapper generates an zipped OBJ file. This is the file you should upload in Sketchfab. You shouldn't unzip it. You can just click it as it is, zipped. Okay, continue. Then you can put just a name or a description to your model while it's uploading. Okay, continue. Here you can see that the model is loading. Let me show you in the meanwhile another model that I have uploaded already in case it takes too much time. Yeah, it's still uploading, so let me show you a model I have uploaded already. Here under your account, you can find your models, my models. Just click on the model you want to visualize. Then there is the full screen. You can rotate, move. Sketchfab has different kind of option. Let's choose, for example, here the shadeless option. You will see a bit different your model. So it's a very easy way. You see it's very light. It's very easy to move around. And it has the magic button, the share button. You have to click here, copy the link, and then you can share it with any of your clients, with yourself. It's an easy way to have always with you your model in order to make demonstrations. You see it's loading, and yeah, that's all. With Sketchfab, it's a very easy and cool tool. Okay, we can go. We can continue. Let's see now how to import the orthomosaic into AutoCAD. We have done already a webinar about explaining step by step with very analytical instructions how to import our orthomosaic into AutoCAD. Let me, okay, maximize the window. So practically what you have to do if you want to import the orthomosaic into AutoCAD, you just open AutoCAD, you take your orthomosaic, drag and drop it. Just click OK to place it wherever. You just need to click OK in your screen, and then the software will import your orthomosaic with random coordinates. If you want to give correct coordinates to your model, you should type the command georefer image, georef img. This is a command that doesn't come by default with your AutoCAD. You should download it and upload it into AutoCAD. For step-by-step instructions about how to do that with this specific command, please have a look at our knowledge page where we have really detailed instructions about that. So once you type this command, software AutoCAD asks you what is the file that you want to georeference. You should click on your orthomosaic, and then the orthomosaic will be lost from your eyes, because it will be it will go from random coordinates to the real coordinates really far away from your interface. To bring it back, you should type the command zoom extend, and that's all. You have the orthomosaic in front of you, georeference with correct coordinates per each pixel. Let's see now how you can import it in ArcGIS. So the first thing you have to do is to open ArcCatalog. ArcCatalog is the application of ArcGIS that helps you to organize the folder structure and generally your dataset. You should create a file geodatabase. Firstly, you have to find where you want to create your file geodatabase. Then with right click, you can choose new file geodatabase. And once the geodatabase is created, you have to go on the geodatabase, right-click, import raster datasets. And then a window will open, and in this window, you have to load all the raster datasets you want to import in ArcGIS. For example, the orthomosaic, the DSM, the NDVI map. They are all raster datasets. And then close our catalog, open ArcMap, and visualize these outputs. once again, for really detailed instructions about how to do all these steps, you should go to webinar 7 made by us. You can find it in YouTube. Let's see now how you can import the orthomosaic in a software called Global Mapper. Let me close previously the software that we are not going to use anymore, so I can make things easier here and we don't spend too much time to load things. Okay, so here it's Global Mapper. It's a commercial software, but it has a free limited version. I would recommend you to ask for it because it's a pretty useful software with many applications. Let's import now the orthomosaic into Global Mapper. Just drag and drop it. The mosaic is loaded. Here there is this button called Open Control Center where you can see the layers. We just have one layer, the orthomosaic layer. You can hide it or bring it back. Global Mapper has useful tools such as measurements. You can do measurements in Global Mapper. Here, this tool, tool. You just need to click the 2 points that you want to define the distance between them, and on the bottom part of your interface you will be able to see the total length of this distance. Let's now import it in Quantum GIS. Quantum GIS is a free software with many applications. It can practically do every application that the professional GIS software can do, so I would really recommend you to download it and have it as part of your workflows. It's very easy. It's very easy to use it. You can just drag and drop the orthomosaic, and here you can see on the left the layers. Okay, we can go now to see how to import the DSM on this software. Here we are in Global Mapper. DSM. Okay. As a first comment, I would like to say that if you have worked a lot with our DSMs, maybe you notice some changes here. Let me make some zoom. This is because this DSM is made with our new version 2.0 that it's about to come. It will be released very soon. You can see that it's a much smoother DSM. Here, for example, let's see how this, I don't know how to call it, it's a bridge, it's a crane, but look how smoothly it has been reconstructed. It's a really improved DSM, and we would really like to receive your feedback once the new release, the new version is online. I would recommend you to try our DSM and the new DSM and orthomosaic and send us your feedback. We would love to hear it. So here I have now one more layer, so I can hide the layer I don't want. Global Mapper has this cool, here it's this button that permits you, okay, it permits you to visualize both at the same time. It's good for some inspection. It's a good tool. Let's import it now in Quantum GIS. Same file, just drag and drop it. Here it is. You may notice that the colors are different in Quantum GIS. This is just a representation issue. It has nothing to do with the information. The information is exactly the same. We can represent the DSM with any kind of colors. Here, for example, under the, you should go to the layer of the DSM, right-click, Properties, and under here at the render type, instead of single band gray, you should choose the option single band pseudo color. Then you have to click the button classify and then OK. And you will see that your DSM now it has colors. I will close this software. So let's import now the point cloud in our software in Global Mapper. point cloud. Just you should import the LAS file. Just drag and drop it. You should click OK. Okay, let me uncheck the rest of the layers that we have. So I will uncheck the orthomosaic and the DSM. Now we have only the point cloud. Global Mapper has this tool here. It's called 3D Viewer. It's not a tool, it's a viewer that you can use in order to visualize the point cloud in 3D. Here it is. You can rotate it, you can come closer or further. You can see also this cute, lovely background of Global Mapper with the sky. This is something that we will also have in our next version. It's a simplified sky, but we will improve, and later on we will have more patterns for background. Okay, I can close now Global Mapper. And okay, let's see now how we can import the index map, how to work with an index map. Let's open it in Global Mapper again. I need to open a new session. Okay, I found an agriculture project because normally we have index maps with agriculture project. Here, index, NDVI. Okay, I will drag and drop this NDVI value, GeoTIFF file. As you can see, it doesn't have color. Practically, it tells us what is the NDVI value for each pixel of our area. The NDVI value normally can be from -1 to +1. Here you can see that in our case, the NDVI value was from -0.46 to +0.93. You may see meters here, but it's something that shouldn't confuse you. It's not really meters, it's not altitudes, it's really NDVI. Let's click this button and check the NDVI value of some of the points of our area. So here you can see height. It's not the real height. Once again, it's NDVI value. It's just the way that Global Mapper reads this information, but practically it's the NDVI. So this is the NDVI value for this specific pixel. It's 0.724. If I want to check the NDVI value on the road, this is a road, I would expect a low value and a low NDVI value because on the roads I have no vegetation. And this is true. Here you can see the NDVI value for my area, for my road is, for the specific point of the road is minus 0.103. If I go now here that I know I have vegetation, it should be higher. Indeed, it's higher. It's 0.482. So this is how you can import an NDVI map in a GIS software and how you can read the information that it has. Another output that we generate, and I would like to show you, let me close this, it's the classes. Let's see what are the classes before I show you the output and how you can generate them. So I'm here, I have opened Pix4Dmapper, I have done my NDVI, my reflectance map, I have drawn an area, a region, here it's a region. I have created the NDVI for this specific region, and now I want to define the classes. Here, you see, I can organize my classes. You can define the number of classes. I will just keep 3 classes in this example. So this means that the software has classified the NDVI, the area I have here, based on the NDVI values of each pixel. Pixels that have NDVI value from 0.71 to 0.93 belong to this first class that has a green color. Pixels that have NDVI value between 0.62 and 0.71 belong to the second class and have this orange color. while pixels that have from minus 0.46 to 0.62 NDVI value belong to this third class and have red color. As you can see here, there is these two, let's say, areas where that you can fill. Let's put firstly the description. So how would you describe this first class that has this NDVI range? I would describe it as very healthy, for example. Of course, this is a very random example. You can put your own comments on it. So you can type very healthy. How would you describe the second area, points that have that kind of NDVI? I would say they are just healthy. And at the third class, I would define it as not healthy or problematic or need more care. You can put any kind of description for your areas. And then in this field, you can set the rate. What is the rate? Well, the rate is something, it's a value that can be read by a special software that your tractor might have. And this is the value that it will give instructions to your tractor about the fertilizer it will throw to your plants or the chemicals, and in generally how to manage yes, that kind of things, how much fertilizer to put on your plants. So let's put, for example, 5. 5 might be 5 kilograms per hectare, for example, and here 10. And at the last class, I will put 20 because it's really not healthy class at all, and I want more and more fertilizer for this area. All you have to do now is to click this button, Export. It's already done. So now what we will get is a shape file with this information, with the classes. Here it is, my shape file for my region. Just drag and drop it in any GIS software. And here is the result. Let me remove the NDVI from the background. So here is the classes. If I click on a class, I will be able to see the information that I have registered for this class. So I can see an average NDVI for this class. I can see my description, my comment. Okay, so this area is very healthy. Now I know. And then I see 5. So I should put 5 kilos per fertilizer, of fertilizer. Another area, okay, this is not so healthy, and I should put 20 kilograms of fertilizer. Let's make now a better representation of this shape file. Here, Global Mapper gives you this option, search by attribute. Please note that these are tools that all GIS software have, so maybe now we use Global Mapper, but you can use your own GIS software. It can be ArcGIS, it can be Quantum GIS, and so on. The concept is the same behind each of these GIS software. So now we have this window, Search Vector Data. Here we want to search by specific attribute. I want to search by comment. I want to search all the areas that are considered to be healthy. So I type here healthy, I do new search, then select all. So all these areas that automatically got selected are healthy. And let's give them now a nice color. Edit selected. Here you have to go create new type. You have to name somehow your new type. I will call it class underscore A, or H like healthy. Then let's put a nice color on my class. As it is healthy, I would put a nice green color. Okay. Okay. And then okay. And then if I close now this window, you will see I have with nice green color all the healthy areas of my area. Let's do it again for the very, how have I call it? Let me go back. I had called it healthy. Or no, I did the healthy. I should do now the very healthy. So once again, we want to sort by comment. Very healthy. New search. Select all. Edit selected. create a new type. I will call it class very healthy, and I will give it a nice color. Okay. Okay. You see? So my very healthy plants are this one with really dark green, and the light green are healthy areas. And let's put, in order to finish with this representation, the rest of the areas that are not healthy. I think we call them not healthy. Yes, we call them here. You can see it, not healthy. Select new set, select all, edit selected, create new type, let's call it class not healthy. Let's put a red color to indicate that something is wrong. Okay. Okay, and then we close the window, and here we have a nice representation of our area. Now we know which part of this area is very healthy, what is healthy, and what is not healthy. And this is a file that can be read by your tractor, and your tractor can automatically go over these areas and put the quantity of fertilizer or chemicals or seeds that you have indicated. Okay, I will not save. And just before finishing, I would like to show you where you can find all of these outputs for which we have talked about. Okay, here it's a project. So in the project folder, you will be able to see four main subfolders. One is called 1_initial. Here it's where you can find all the outputs of the first step of processing. In this webinar, we haven't talked at all about the outputs of this step of processing. In the subfolder 2_densification, you will be able to find the outputs generated after the second step of processing. So here we will go to find the point cloud here under the subfolder point cloud, and the 3D mesh under the subfolder 3D_mesh, where you can find all the output file formats for which we spoke today, OBJ, you see here the zipped OBJ, PLY, 3D PDF. Let me show you also the 3D PDF as I am here. So the 3D PDF, it's another file format that you can send to your clients. It's an easy way to share information with your clients because it's a very light format. Here you can rotate and visualize your 3D texture mesh. It can be sent by a simple mail, and it's a good way to share your dataset. Okay, let me close. If I go back to the main folder, then under the subfolder 3_DSM and orthomosaic, you will be able to find the DSM and the mosaic, the GeoTIFF files for which we have been we were speaking today. And then under the subfolder 4_index, you will be able to find some the indices you have created. For example, for this project, I have created the index map called red. And here there is a GeoTIFF file that has your map. It is your map, your index map, and then you can find this shape file that practically is the classes, the file I just show you. Okay. So that's all from my side. You can always enter in our page, Pix4D.com, in order to get a free trial of the software. Especially now that we have our new big release 2.0, I would recommend you to enter to our webpage and subscribe in order to get informed about new releases. And then you can also buy or rent the software. You have access to our support page and so on. Yes, let me see if you have any kind of questions that haven't been replied by our support team till now, so I could also reply you. Okay, I see that everything, well, yes, everything was replied. more or less, yes. And so I suppose I can close this presentation. I hope you enjoyed. I hope you learned something today, and I hope to see you soon in our next future webinars. Thank you for attending.